Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called SLIDE-OKU number 0, a penguin adventure by Jekyll. And here are the rules. We have Sudoku, normal 6x6 Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 6-cell region contains the digits 1 through 6, exactly once each. We have Kropki dots, where digits separated by a black dot have a 2-to-1 ratio. That is, one is double the other. And not all black dots are shown. We have ice sliding, where we need to draw a path from the penguin to the shrimp. And the ground is covered in ice. So when the penguin starts sliding in a direction, it cannot stop until it reaches either a wall or a rock. And the path can cross itself, but not overlap. How does that work? Can penguin go diagonally? I don't think so, right? Maybe it can go diagonally. I'm assuming you can only go horizontally and vertically, but that could be wrong, right? Huh. Interesting. Anyways, we have rocks where all rocks share the same digit to be deduced. So all the digits on the rock are the same digits. And in this puzzle, the penguin's path is a valid parity line, which means every pair of consecutive cells along the line must contain an even and an odd digit. So say the path was something like this. Oops. Say the path went something like this. Well, let's just do that for now. Then out of these two digits, one is odd and one is even. And out of these two digits, one is odd and one is even. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, this digit is in a 1-to-2 ratio with two other unique digits because they're in the same box. So from 1 through 6, the only possible digit that could be here is 2 with 1 or 4. So this has to be 2, and that's in a 1-to-2 ratio with 1 or 4 here. Remaining digits in this box, then, are 3, 5, and 6. This is in a 1-to-2 ratio. It could be 2 with 1 or 4. Or it could be 3 6s a pair. We don't know. Same with this. This could be 1, 2, 3, 4, or 6. The digit in the stone is 3, 5, or 6. We're not sure. Yeah, I'm not sure what it means. Like, what it means you can't... The path can cross itself, but not overlap. I don't know what that means. And the thing is the path, like, can you go diagonally? Because otherwise, the way I see it, if it can't go diagonally, you have to go that way for the shrimp to get to the shrimp. The penguin has to go this way, and then it has to go there. But then it's kind of, like, stuck about how it can go. I guess it could go, like, something like this. Oh, it doesn't have to... Okay. You're right, it doesn't have to go that way. So I guess it could go that way, It can't go this way because it'd be stuck. That way, but then it has to cross, right? Then you could go that way, that way, that way, that way. That is possible. But then is that considered overlapping? I don't know. Uh, yeah, I'm not sure what that means. I think that's the only path you can really go, though. There's no way you can actually... If you're going horizontally. If you're going diagonally, then... Sorry, if you're going orthogonally. If you're going diagonally, then all bets are off, right? But I'm assuming it's going... Can't go anywhere else from here. So then you have to go like that way, right? Can't go that way because you get stuck here. So you have to go that way. You can't go anywhere else but this way. You have to go that way. I guess overlapping means you just can't backtrack or something. I don't know. So then you go that way. Then you have to go that way, that way, that way, that way. So these are going to be the same set. So we'll mark them as green and pink. Therefore, that's green. This is pink. That's green, pink, green, pink, green, pink, green, pink, green, pink, green. So this cannot be 2 and 4 as a pair. It's 1 and 2 or 3 and 6. Green, pink, green, pink, green, pink, green, pink, green, and pink. Okay. What does that mean then? So we know the stone has to be of type pink. So because we have in column 5, we have green, pink, green, pink, green. So we have 3 greens and 2 pinks. So the stones are all pink. Since those are pink, we have, that means this cell must be green here. This cell, if this is 1, that's 4, which is opposite parity. If this is 4, that's 1, which is opposite parity. So if this is green, this has to be pink here. We have 3 pinks in box 5, which means the last cell has to be green. So greens are even, and pinks are odd. Well, this is in a 1-to-2 ratio with another digit, and it's odd. So it can't be 2 or 6 here. It has to be 3, which makes that 6. That 3 and 6 eliminates 3 and 6 on the stone cells. Shoot. That means we have to have this be, the stone be 5. And this is pink again. This is pink, that's 1, which makes that 4. That leaves this as a 3 and this as a 6. This is an even cell, so that's 2 and 1 here. That's even, so that's 4. This must be even, but it can't be 2 or 4. That's 6. This can't be 3 or 6. It's even. It's 2, which makes that in 1-to-2 ratio with 1 there. Wait, we have a contradiction. That's 1 and 1. Wait, we have too many... How? Shoot. Yeah, the stone has to be... The problem is I don't know if this path is correct, right? Because I don't know if that's considered overlap. I guess probably not, but then we have a problem, though. all the stones are pink, but then you have pink here. Um, these are definitely opposite if this is the path. But I don't know if this is the correct path. That's really the issue. I think it has to be, but um if this is pink, this is green. But then this has to be green. But that's not possible. Because 1 and 4 are opposite parities, right? So they can't be green and green. But in this case, they would have to be. Uh, mm, huh. That's it. Anyways, this is a 3-5-6 triplet here, which eliminates 3-5-6 in the rest of the column. So no 3 or 6 here, it's 1 or 2. So this must be a 1-2 pair here. Um, hmm. I'm super confused right now. Hmm. So a couple of things. One thing is they should say whether you can go only orthogonally or they can go potentially diagonally. I'm assuming you can only go orthogonally because that doesn't really make any sense if you can go diagonally in all these directions, right? Then there are multiple paths you can go down. But the problem is I'm running into a contradiction here by doing that, right? Penguin can only go if it only can go orthogonally. That means you have to go that way, right? You stop at before the stone. You go that way. You go that way. You get blocked by the stone. Blocked by the stone. Blocked by wall. Blocked by stone. Blocked by wall stone, and then continue. Green, pink, 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 green, pink. Um, could you go a different direction? I don't know. Maybe, maybe not. Yeah, this is the problematic part, right? The rocks have to be all the same digit, so they're the same parity. But we have 3 greens here, therefore the rock has to be pink. But if this is pink, we have 2 greens and group pinks in that row. So then this would be green. But these are opposite parities because they're 1 and 4. So this is green. If this is green, this is pink. But then we have 2 pinks here, pink here, pink here. We have 4 pinks in column 2, which doesn't work. Um, this has to be 2 greens here, which leaves that as pink. We have green, green there. So that's green. But the problem is we have 3 pinks here then. This doesn't make any sense. This is green, that's pink. Pink, that's green there. These both have to be green. But then 2 is not going to be in a 1-to-2 ratio with 4 and 1. So this just doesn't work. I'm so confused by this. Um, huh. So there are multiple paths then you could take? So okay, so then this is saying that this can't be the path. I don't like that. Yeah, I don't really enjoy that type. You can't go back that way. You can't go there, you can't go there. You have to go this way. You can't go here and then go back. I guess you have to go this way, this way, this way, this way. So I guess what they're saying is, yeah. How would I phrase this? I think part of the issue is the rules, right? I feel like that the rules should basically state something. There's multiple problems with the rules, I feel. I think this is a problem of clarity though. It's not like there's nothing inherently wrong with the way that they say it. It should say probably something along the lines that there are multiple paths for the penguin to get to the shrimp, but the correct path um, still gives us a valid Sudoku puzzle. Hmm. I don't know. It does go this way. You can go there. You can go there, and then you have the problem again of basically, yeah. So this is the only one way you can go. Like, so here you only have one way to go. You can only go that way. Here, you can go either that way or that way. But since first of all, overlap is confusing. So I guess they're saying you can't go trace yourself back because, again, I think like you can enter a cell more than once. That's kind of the problem. I don't know. Maybe this is just I don't know, semantics. Anyways, this can't go this way because that would overlap it. And the thing is, yeah, it should say you can. So okay, there's multiple things that I would say. One is you need to draw a path in the whatever blah blah blah. There are multiple potential paths, but the correct one is one that solves this puzzle correctly. You should say something along those lines there. Because the way that it's phrased implies that there's only one path, and so there's only one way to go. But there's actually multiple ways to go. It's just that you have to choose the one that actually fits the actual puzzle. And then also, I think you should say something along the lines of the penguin can only move orthogonally. It cannot move diagonally. Because there are other paths potentially that could be moved diagonally. And, I mean, I've seen some of them like that. So that's another thing. And, yeah. And then, like, basically, the penguin, I would not say overlap. It cannot retrace its path, I would say. Because here it's retracing a path if it goes here and then it goes here and then goes back here, right? So because of that, we know you can't go this way, you can't go this way, you can't retrace your path, you have to go this way. This way you could go this way, but the problem is you would be retracing your path by going this way, which is not allowed. So then you have to go this way. This way you can't go here, obviously, so you have to go here. This way you could go either of these two paths, right? But we find if we go this way, you're sort of stuck. You have to go this way. You can't go here. because you could go here, but then you'd be retracing your path. You can't if you go that. So if you go that way to go that way, you're retracing your path. If you go this way to this way, you're retracing your path. So you can only go this way then. This one you can't go that way. You can't go retrace your path that way, so you have to go that way. This you go here. You'd be retracing your path going that way, or that going that way. So therefore, you have to go there. So that's why this is kind of confusing. But anyways. So we have this. So with this assumption then, green, pink, 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 green, pink. Okay, so that solves it, I think. So here, this must be pink. That leaves this as green. This would have to be all the rocks are pink. So these are pink. We have 3 pinks here, so this must be green. These are opposite, so this must be pink, which means this has to be green here because we have 3 pinks in row 6. That leaves these as pink here. We have 3 pinks in row 1, so then we have to have green, green here, and this is green here. And we have 3 pinks in column 2, so this is green. So this is, yeah, this is the correct path. So this is 2 and 4 to be the same parity. So that's 4, this is 1. These are the same parity, so they have to be 2 and 4, which means this has to be 6 here. So 6, the stone cannot be 6 because they are pink parity. This is 3, 5 as a pair. That forces this to be 6. This is pink parity, so this must be 3. Can't be 1 or 5. 3 eliminates 3 there, so it's 5 and 3. All the stones are 5. 3 is in a 1 to 2 ratio with 6. That leaves this as 4. How did I get 9 there? This is 6. Remaining digits here are 1 and 2. Pink is 1. That's 2. That leaves that as 3. This is 1. This is 3. That leaves that as 6. 2 and 4 are there. Remaining digits in column 4 are 2 and 6. This can't be 6 because of 6 in the row, so we have 2 there, 6 there. Remaining digits in row 2 are 1 and 4. That's 1 and 4, since that's pink. That leaves that as 6 there. Remaining digit in column 5 are 3 and 4. So this is 4, that's 3. Remaining digits in column 6 are 1 and 2. So this is 1, which makes that 2. That leaves that as 4, which makes that 2 and 4 there. That leaves that as 2, so this is 3 and 1. Yeah, so I think there should be some clarification in the rule sets here, because otherwise, obviously you get to the incorrect path, but that is potentially still a valid path, right? And it's just, it should be clarified. First of all, you can only go orthogonally. Second of all, there are multiple paths, but the correct one is the one which can solve this correctly. And then third of all, you cannot retrace a path, I would say, instead of overlap. Because overlap, technically you're overlapped here, right? Which is why it's kind of confusing. So, yeah, I would say that would be the better way of phrasing this puzzle. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.